4, 7. Example 4, we're going to write another coordinate proof. And so we're kind of at basically the pinnacle of this particular section as far as difficulty. And we're going to combine everything we've learned from examples 1, 2, and 3. And they're all getting dumped into this one, into example 4, doing a coordinate proof. So here's our situation. Given angle B is a right angle in triangle ABC. So we already know we have a right triangle called ABC. D is the midpoint of AC. And we're to prove that the area of triangle DBC is 1/2 the area of triangle ABC. Now what makes this different from example 2 is example 2, we actually had numbers. We actually had lengths for these different sides. We knew where they were positioned in the coordinate plane, and so we could count the boxes. And we know nothing. We don't have any inkling how long these sides are, so it's very vague. It is a doable problem. We're going to have to assign some coordinates, okay? I love this point because this makes so much sense. Let me see if I can explain it to you. And if you don't get it this time in the video, I'll try and talk you through it in class tomorrow. Since you're going to use the midpoint formula, and also not only the midpoint formula, but also area, because we got to find the area of triangle DBC and compare that to the area of triangle ABC. All those formulas have fractions. So if you look at the area of a triangle, that's 1/2 base times height. If you look at the midpoint formula, we add our x's and end up dividing by 2, and we add our y's and we divide by 2. So knowing this, knowing that we're going to divide by 2, this hopefully makes sense. You want to use multiples of 2 for the leg lengths. Because if you take half of an even number, half of a number that's actually a multiple of 2, you won't have a fraction. You'll end up with a whole number, or just simply, in this case, a letter. Very interesting. And I want to bring that to your attention as you're thinking through these things and you're going, hey, I have to use this formula where I have to take half of a number, or I'm dividing by 2. Be intentional and use a multiple of 2. It's really simple, and I'll show you how to do that. So let's call the coordinate of A, okay, and that's with the understanding that you yourself are going to have to draw this picture, okay? So here's your y-axis, here's your x-axis. You know that you're going to end up drawing some sort of a right triangle right in here, okay? And we know it's a right triangle because it told us that angle B is a right angle in triangle ABC. We know that D is the midpoint, so we're going to actually be splitting AC into 2 equal pieces. And we've got to prove that this triangle formed when you connect B to D. Now we have triangle BDC or DBC, that it's actually half the area of the big triangle ABC. Mimics, it really does parallel what we're doing here, okay? So as you're looking at this, you're like, well, I don't even know what to name this point. Well, what they're telling you in your hint in the blue is don't just call it a single letter, like make it a multiple of 2. So whether you call it 2A, 2B, 4A, 6A, you know, whatever letter you want to use. They're using J. They're calling it 2J. They want that, the name of this point, this distance, to be 2J from the origin to here. They don't want to just call it a single letter. They want to double that to make it a multiple of 2, so that when you put it into these formulas, you don't end up with fractions. That'll drive you crazy if you do that, if you just do a single letter. So that's why they're advising you to use multiples of 2. So in other words, just whatever letter you pick for the distance, multiply it by 2. That's a multiple of 2. Okay? So if I'm going to call this distance right here 2j, so that means the name of this coordinate at point A, remember it's a y-intercept, so it'll be 0, 2j. Okay, see that? And then this point, that's an x-intercept. So remember, whatever letter I call that, and they're, in this particular problem, they're calling it n. So I'm going to double that and call it 2n0, just to make the math a little bit easier. And of course, the origin's at 0, 0. Okay, now if this part right here was confusing, okay, they didn't give me a length. I have no idea how long that segment is. All I know is I should assign it a variable of some sort, because what do we do when we don't know something? We assign it a variable. All they're asking you to do in the blue right here, all they're asking you to do is double your length of your sides. So it's a multiple of 2, so when you put it into these formulas, you won't end up with a fraction answer. Okay, it'll be a little bit easier. Okay, so hopefully I've explained step 1 very, very well. And in step 2, I positioned the figure in the coordinate plane. I made my right angle B. I made that the origin. And then I positioned AB on the y-axis and BC on the x-axis. So I kind of did a couple of strategies there. So now I'm going to do a coordinate proof. And the first thing I want to do is I definitely want to find the area of the big triangle, first of all, okay? And to do that, I've got to do 1/2 base times height. 1/2 base times height, okay? Well, remember the base is BC, and the length of that is 2n, 0 to 2n. The length, or that base, is 2n, okay? The height is going from 0 on up to 2j, so the height is 2j. So when you put this into your formula, you'll have 1/2 2n times 2j. So if you take half, if we do this part first, you take half of 2n, that's just n times 2j, or in other words, 2jn, okay? Or 2nj. However you want to whatever you want to call that. I usually go alphabetically. Your book kind of did a little bit differently. But this is the area of triangle ABC. That's the area. So we're going to hold on to that. That's important. We just found that area. Okay, we did what we did in example 2 with that big triangle ABC. They just knew what the numbers were. It wasn't vague variables. It was something actually known, okay? All right, now I need to find the location of the midpoint. See, I can't tell. I'm not on graph paper. I don't know where point D is. I don't even know the name of that point. So what I'm going to have to do is I'm going to use my midpoint formula, and I'm going to come back here to the coordinates for point A and the coordinates for point C. A is 0, 2j. Point C is 2n0. And I'm going to use the midpoint formula to figure this out. So I'm going to add my x's. Okay, so I'm 0 plus 2n and divide that by 2. Okay, 0 plus 2n is 2n, and 2n over 2 is just n. See how cool that was? I didn't end up having a fraction that I have to deal with and use that in my math. That's wonderful. That's why we double what like we did. Okay, now I'm going to do the same thing for the y's. I'm going to do 2j plus 0 over 2. So that's 2j over 2, which is j. So my midpoint is going to end up being nj. That's point D, is nj. Okay, hopefully that makes sense. That's n is half of 2n and j is half of 2j, so hopefully that makes sense to you. Okay, now remember what we did in the other problem. We said, you know, the y is the distance, that's the height of the smaller triangle DBC. So triangle DBC has the same base as the big triangle, so that would be 2n, but its height is only j. Okay, the height is j, which is the y coordinate of your midpoint. Okay, that's going to be true every time you do this. All right, so now the last thing is we need to calculate the area of this triangle now that we have all the players. So we've got 1/2 of the base, which is 2n, times the height, which is j. Let's go ahead and do this part first. Let's do 1/2 of 2n. Half of 2n is just n, and so we end up with nj or jn. Okay, doesn't matter. Nj is the same thing as jn. And so now, as you're comparing the two, is jn, is that half of 2jn? That's what you're asking yourself, because that's what we're supposed to prove. And the answer is yes. If you took half of 2jn, you would get just jn. And so we were able to prove that triangle DBC is exactly 1/2 the area of triangle ABC. We were able to prove that. Now that is very complex. That made my brain hurt. But that's how you do it when you don't know exact numbers. So I'm sorry it was so vague and weird. We can talk more about this in class. Bring your questions, write some questions down in the margins. Like if you didn't understand what I was talking about with the multiples, write that down so we can address it. And just mark in your coordinate proof here where I lost you, okay? And I will talk to you tomorrow about it.